Welcome back for section 11.5. 11.5 should be another pretty quick one. But what this basically is we are making inferences. So this is the ability to draw a conclusion of something. This is the ability to look at some data and come up with some information about it. But this is about making inferences, and then it is also sample surveys. So we are making inferences from things that we've, or information that we've gotten, data that we've collected, things like that. So we're making inferences from sample surveys. Okay. Now there's two big definitions that come in this chapter, section. One of them is descriptive stats, and the descriptive stats are basically how you organize and collect and summarize and display the data. So it's organizing, displaying, summarizing. It's how you look at all of the data that you have. Now, 90% of the time, what you're going to see is you're going to see a table, kind of like the two-way tables that we did. You might see charts. Most of the time, though, you're going to see things like two-way tables. Okay, so that's what you see with the descriptive stats. Now, inferential, these are the conclusions that you're going to draw. So inferential stats are the conclusions that you're going to draw about a population. So conclusions about a population. So this is all about conclusions with a population. So we're actually trying to come up with things after we've seen that data. Okay? So also, one thing that you have to kind of pay attention to is we can kind of make predictions based on things. So when you look at this, we're kind of looking at a prediction. Okay? So like for instance, if I wanted to estimate the average height of the juniors in the nation, I could look at all of my algebra class as a sample. I could then use my algebra class to figure out the average height, and I could probably use that as a decent prediction for average heights of 17-year-olds, right? That could be a decent estimate. Now, is it going to be perfect? Absolutely not. Is it going to be something that I could maybe run with? Sure, I could at least try it a little bit, because I have, 100 juniors. My sample size is 100 people. That's quite a few people to be testing, and that's also a pretty good range of people to be testing from short to tall, right? I've got a lot of short people, I've got a lot of tall people, so that's a pretty good range, right? That doesn't mean that it's perfect, but it allows me to at least draw a conclusion while being somewhat informed, because I've actually gone through some of the work to find it. But if you don't go through the work to find it, you're not going to be able to make any inferences. Now, this is an interesting question. So on page 627, there is there's a question where it says, a student wants to predict the winner of a mayor's election. Two candidates, candidate A and candidate B, are running for office. 8 staff members conduct surveys of randomly selected residents. The residents are asked whether they will vote for candidate A or not. So this is what it looks like. This is their sample size. This is the number of people that will vote yes. And this is the percentage of the people that will vote yes. So this is just a conversion of the percentage. But the first person asks 5 people to say yes, and that's a 40% response rate. The next person says 12, and then we've got 4, and then 33.33% response. 20, I'm just going to do them all. 30, 50, 125, 150, and 200. And then 12, 17, 29, 73, 88, and 118, 60. And sorry, almost done. Alright, so these are all of the percentages, the totals, and the samples. Now, there's a couple interesting questions with this. The first question says, based on the first 2 responses, will this candidate win? So we look at this, and we're assuming this is coming from a very similar community, this person is, or these people are asking people from a community, and they're asking people, whether they're going to vote for people or not. And typically communities share pretty similar demographics, right? Like if you look at Frankenmuth is probably a fairly conservative area, which means that a lot of those people share the same demographics. Now, is that everybody? Absolutely not. But it is something that you could at least, kind of think that you have a pretty decent, if you get a pretty decent sample, you're going to see the way that the community swings. So here, it wants me to look at the first two samples, this sample here and this sample here, and it says, based on this, will he win? And obviously he won't win because it's less than 50%, right? You have to have more than 50% in order to win something. So think of this, but he only asked 5 or 12 people. The more people that he asks, the more accurate it gets. So now it says, the next question says, based on the last example, or based on the end results, is he going to win? And now if we look right in here, he's at a 59, this candidate is at a 59% approval rating, which means that based on that example, he's going to win. So we're going to see that based on this community, the further we go and the more we actually, the more we test, the more accurate my results are going to be, right? Like if I asked what the best lunch at the school was, 90% of people would probably say chicken tenders. And they would say that those are the best things, they love them, they're the greatest. But if I find 2 people that hate chicken tenders and I say, hey, do you like these? And they say no, and I go, well, I've asked 2 people and 0 have said yes. That's not a good representation of the population. So the best way we can represent the population is by asking enough people to be able to actually get responses, to be able to get results. Okay? Now there's a really, really easy way for me to calculate how accurate my results are probably going to be, and that's something called the margin of error. Now what margin of error actually does is it tells me what I can expect my range of accuracy to be. So if I've tested, or if I have asked a whole bunch of people, I'm going to be able to test how close my response is to being accurate. Okay? So the way that you do that is by plus or minus 1 over the square root of n, and n equals the number of responses, or the number of people in the sample, whatever you want to call it. So, for instance, if I ask 100 people something, if I ask 100 people something, I'm going to do plus or minus 1 over the square root of 100, which means that that's the same thing as plus or minus 1 over 10, which is plus or minus 0.1, which equals plus or minus 10%. So basically what I'm going to do is I'm going to go 10% up and 10% down from whatever my response was, and that's the range I can expect for something to be true. Okay? So let's look at a question. It says a survey of 375 people responded. So 370 people responded, and it said that 42% of them will vote yes on a candidate. Now it says, what would the real range of the population actually look like? So this might not be a very good representation of what the actual approval rating would be. So the way that we figure out the approval rating is plus or minus 1 over the square root of 375. And this is something that I just want you to type into your calculator. And when you type it into your calculator, remember your parentheses, but this is going to be plus or minus 0.052, which means the same thing when we convert this to a percentage, it's going to be plus or minus 5.2%. So I'm going to take 42 minus 5.2, and I'm going to do 42 minus 5.2, or plus 5.2. So I'm going to end up getting 36.8% and 47.2%. So I can expect the real range of my responses to be somewhere in this neighborhood. I can expect them to be somewhere in here. I can expect 36.8 to 47.2% of people will vote yes on this candidate. Okay? I asked a decent enough sample size to try to get a feel for the population, but this is telling me that I am actually getting somewhere in this range for an accurate response. Okay? Now that means that the more people I ask, the smaller my percentage will be. The smaller my percentage is, the more accurate my responses are going to be. Okay? So that's the way that you have to kind of think. Now there could be another style of question where it says something like the response for yes was something like, I don't know, 37% to 46%. Now the easiest way, and then it says how many people were surveyed. If they do this, we just have to kind of reverse engineer. What we're looking for is we want to find the number, we want to find the number directly in the middle of this, so the way that we're going to do that is by finding the average. So 46 plus 37 divided by 2. 46 plus 37 is going to give me 83, right? So 83 divided by 2, 83 divided by 2 is 41.5%. Okay? Now when we find the number that's directly in the middle of that, I need to figure out how far apart 41.5% is away from this, and I can see that it was 4.5%. So that means my margin of error was 4.5%, right? So if my margin of error was 4.5%, then all I need to do is take 1 over the square root of n equals, I'm going to change this back to a decimal, that's 4.5%. I'm going to multiply each side by the square root of n, so it's going to be 1 equals 0.045 times the square root of n. I'm going to divide each side by 0.4045. So I'm going to get, and I'm going to erase this stuff on the top here. Alright. So I have 1 divided by 0.045, and that is 22.2, and that equals the square root of n, and then we square it on both sides to get rid of it. So it's going to be just under 494, so 493 people. So that tells you that 493 people were surveyed with this. Okay, that's pretty much all there is for margin of error. That's pretty much all there is for descriptions and inferences. You have to be able to draw conclusions from those things. If you have questions, shoot me a message. Let me know. This should be a pretty quick section for you because there's only one formula that you need to use for it. So if you have any questions about it, make sure that you let me know. All right, see you later.